help us, right?
Yeah.
Okay, cool. Because on this one, when we solved, what ended up happening? I shouldn't say because. When we ended up solving, what happened? Tangent of theta equals, what'd you guys do? Pretty cool. Gotta plug in. Big ol' absolute values. True?
Yeah.
Good. So question. M2 was our negative 3/4, right? And then minus M1 would be the number 2. Then we have 1 plus multiplying them together. What do you have to be careful of, my guys that are fraction phobes? The fractions. But we got this. Brandon. Multiply by the reciprocal. But problem, can we do that yet with this little 1 plus a chillin' down here? No. We have to simplify some stuff first. Now, one way of simplifying is tangent of theta equals, who wants to simplify this? Isn't it kind of messy?
I did.
I really wish there was something cool that we could multiply top and bottom by to get rid of all of our fractions so we didn't have to stress. Does anybody remember my really cool trick as to how to get rid of complex fractions and make them look pretty again? The highest denominator. What's the highest denominator? What's the common denominator? 4. I should say the least common multiple. So if I multiply the top and bottom by 4, now hold on, if I'm multiplying top and bottom, what do I have to make sure to put in? You can get rid of any complex fraction. Why am I showing you this? Because people make so many mistakes with these. You can multiply top and bottom by the least common multiple of the little baby denominators. 4 is going to cancel both of the fractions out, and you have to distribute. I know it looks messy, but I'm preparing you for future math where this is just the tip of the iceberg. It's one little baby piece of a harder, different problem. What is, follow the arrow, 4 times negative 3/4? What is 4 times negative 2? Okay, let's do minus 8. Is that okay? 4 times 1. What happens here? 4 times negative 3/2? Negative 6. Good. The 2 and the 4 reduce. 1 and 2. 2 times 3 is 6. So then can't I make this? Forget the absolute value. Can't I just make it negative 3 minus 8, negative 11, make it positive, so positive 11 over. 4 minus 6 is negative 2, make it positive, positive 2. Now what did you do? Because we're not done. Yeah, I have to go ahead and say theta is equal to tangent inverse of 11/2. And what'd you guys get when you plugged in chugged? Because that's not unit circle. Square root of 3 over 3, 1 square root of 3. Nope. 70 what?
79.7. Well, wait, 3 decimals?
Yes, please. 695. Wait a minute. Does that number seem familiar?
Should it be familiar? Was it the same problem?
What did we do when we solved it the other way? Got the same answer. So do both ways work? Okay. All right, thanks. Thanks, yes.
Oh my god.
Alright, so what you guys do for this one?
Don't talk to me.
Oh, I didn't know how to check
Same thing. Now hold on. Let's make sure you made no mistakes. Weren't you supposed to get y by itself? What did you guys get for the first one? Oh, come on, you're supposed to do this one. What happened? Oh, alright, then do this one fully and don't get stuck by the complex fractions. Will do as in won't, right?
Yep.
Okay, true. Then I'm going to email around campus seeing where my Bible went to.
Missy.
Huh?
Wait.
Ah, what happened? I put down my stylus and it went to pre-cal. You guys want to go back to probability?
Oh no.
No? You like this better?
Yeah.
god.
Okay.
It always is. It always is.
That's so smart.
Guys, Ella's bored. Hurry up.
Ella's bored. I'm sorry, Ella.
Yeah, Nicole. Yeah, Nicole. Yeah, go ahead. You'll be shaking like crazy. No, Luke. I don't know what Nicole's doing.
I hear my name, but I don't know what to say.
That's what it is.
Is that
I got it.
I hear my name.
Wait, you want to stop me?
Guys, let's do that.
How about that tangerine person, guys? Let's do this.
I know. Jeez. The shade.
It's soccer ball really hard, like really hard medium, and I got it wrong. And then we were actually hit the goal.
Oh.
Her glasses fell and they
Did she open it?
I was there to call it fast. Oh yeah, totally. Since then, that's what she was. Pretty rude.
So you should get 5. Isn't it 5, 6, 5? Yes. Yes. She was expecting to go and bring food. We all bring food to eat. We eat good. We eat good. Can we drink this? Plug it in, plug it in.
Alright, kiddos.
We're so close.
Who got 51.155?
Give me a minute. Hold on 1 second. I'm done.
You got that, Sean?
1 second.
You got
We're still going? Okay, hold on. I'm going to start solving.
We're still going. We're still going. We're going strong. We really are going strong, Missy. You should be proud.
I'm always proud.
Ooh.
Okay. Okay.
You just said it works. I'm always proud.
Oh, that could come across wrong, huh?
Thanks.
Yeah.
Rise to expectations.
Okay. We could get it. We could get it.
You got the.
Did you get 1.24? 31 over 25.
Alright, help me out. Do my slopes look good? -5 halves and 3/5?
Yes, they do.
Okay, cool. How's my formula go? How'd you guys plug it in?
Okay, so we have 5 minus -5 over 2.
Good.
Yeah. Oh yeah. Over 1 plus parentheses. Oh yeah. Negative.
Ooh.
Whoa.
Okay, that's what I did.
Whoa.
Okay, now we have to simplify, right? But was this one kind of nice?
What is the plus there?
Isn't that the formula?
Yeah,
That's
it's
a-
plus.
Oh, it's plus.
The bottom is plus.
That's
and
why I'm
the top
getting
is
it wrong every
minus.
time.
Ah, Luca, change it.
Oh, I see.
Okay, so then coming back, we have, coming back.
I see.
3/5 plus 5/2, safe place, make it a safe place for all. 1 plus, ooh. Hey, now can we make it minus because it's plus and negative?
Yes.
Because it's plus and negative?
I'm not gonna lie.
What'd you guys multiply top and bottom by? 10, right?
Yeah.
You know what?
They're so nice.
I was like, okay, guys.
I know fake man.
Yeah. Everyone know how to take
You should go to a soccer camp in Mexico.
Yogurt chips. No,
Is that white chocolate chip?
no yogurt.
Alright, what happened when we multiply top and bottom by 10? Sorry guys, there's all kinds of stuff going on here.
Right?
Everybody.
Let me see.
That's not encouraging.
Alright, so 36.
Multiply it, 6, good. Plus, multiply it.
Wait, what?
25.
All over, multiply it. Multiply it.
Wait, if you times 3 by 10.
How did I lose you guys? Wait. 3 times 10 is 30 over
Oh, divide.
5.
Oh, haha, got it now. That took a
50
second.
over 2 is 25.
Gotcha.
Or you can think, doesn't the 5 and the 10 reduce to 1 and 2?
Okay. Ooh.
2 and 10 reduces to 1 and 5, and 5 and 5 is 25. Was that your question?
Kind of. I was just wondering if you were plug that or reduce on it.
I'll get it right.
Boys, so
I was just, okay, I was just reading that.
No, you could. I'm trying to get you guys ready for complex fractions. So, 6 plus 25 is 31 over negative 5. It's an absolute value. Don't I just get 21 over 5? Cool. So, theta equals tangent inverse.
31?
Oh, yeah, I can. Good catch. 31 over 5. In degrees, what'd you guys get?
80.838. Oh, that was so nice. That was wonderful.
That's what happens when we're all working together.
Aww.
Sure.
There we go, fam.
Sure we will.
Leave me alone.
Are we okay? Alex, are you good then? Do you have a question?
Really into this. I need to show you.
I'm not so sure.
What?
Although it is a really nifty complex fraction trick. Done. Going over homework questions tomorrow. Don't got time because you guys have pictures to write. Ready, set.
Oh,
So 10, I'm guessing 10 is kind of long if it's not due till
I took
Friday.
Wow.
Yeah,
I got a 93.
that's still 2 days to
Phonics?
Conics.
Oh, he has to draw these basic phonics. Oh, you already
Oops. Aww. Boys are playing with this. What's going on up here? It's 2 of these, top to bottom. What do the little color slices? Hey, I just gave it away. What is this indicating? What are you doing to the cones?
Slicing and dicing.
And if you have 2 of them, you're slicing through both of them. Now if you slice through one way, what do you get? What's this guy? A parabola, right? And that's if you go the positive way. The boys were playing with this, not you guys. What if you slice it this way? What's that? It's an ellipse because it's a circle but it's squished, right? Now, pretend this part was still on there. What would this part be? Everybody slice it this way. Circles, right? So if you slice a cone, you get a circle, you get an ellipse, you get parabolas, and if you slice a double cone, double neath them, what do you get? What's this guy with the parabola on the top and on the bottom and with these asymptote things? Hyperbola.
Draw these.
Hyperbola.
Do we have to draw these?
Well, I guess you don't have to draw them perfectly, but they're not that bad, are they?
Could be argued.
This chapter you're going to want to draw at least a little bit.
Okay.
Hey look, it's a triangle. No, it's a V. Then just do like a, yay, I can draw.
Okay, we'll try.
Then do another one, but do like an A. And then do
A.
a little bigger.
It's,
Say, yay, I can draw. And then just do like a dot, 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 dot in the back.
okay.
I just did an accident.
Little mine are different sizes.
Okay, me three. If you want to be super snazzy, how can you do this easier?
Go in next and then make circles.
Say, yay, I can draw.
Yeah.
That works too. Now, then you can go ahead and if you want to, you can color code stuff. If you want to be super snazzy. You can show that. You can show this one.
This might take a second. Yeah, we might do it.
You can show your parabola. You can show your wouldn't that be your lips?
It sounds funny, like.
Shouldn't be that way, should it?
No, like he's funny the way he sings. It's not like he's actually. I can never be on stage.
No.
I don't have that. No, I've heard it in school, I'm sorry.
Why are you coming to next school?
Guys, we're gonna drink higher next year. Yes.
There you go. Ellipse, parabola, hyperbola, circle. But the circle looks kind of squished just because it's three-dimensional. But guys, what's the difference between the top ones and the bottom ones?
Wait, what you say?
Well, there's a top row, and they have a highlighted thing that's kind of small. Can you guys just tell the difference between the top row and the bottom row? Yes. No, seriously, you guys.
Oh wait, are you serious? Where does it say?
2020, right there.
I did not see that.
You're just throwing out the vocab.
I was so confused. I was so confused.
Now, here's the weird thing. The basic conics have formulas that go along with them. The degenerate, it looks like a basic until you try to simplify it and then stuff cancels out. So the basic conics, the basic formulas you're going to see for each of these, something could become zero, something could cancel out, and it could actually end up becoming a degenerate. You think of the basic goes through, the degenerate kind of skims. Do you see what I mean? The basic goes actually through the solid figure. The degenerate, well this plane is just like right between the point. That's all it gets is the point. This one is all along the side. It's not going through. I mean, it is at the point, at the middle, but it's skimming the two cones. And this one, if you had a plane going straight down, it technically is going through. But if you go straight down in the very middle, all you get is intersecting lines. All you get is intersecting lines. So technically, point, line, intersecting lines could actually be defined as, well, degenerate, but conic sections. So maybe you should have learned conics before you learned lines. What?
Mind-blowing.
And all of these come back to one equation and different variations of it. You guys see the standard form equation in the bottom? All of these shapes come from some variation depending on who A, B, C, D, E, F, G, nope. Has to be a zero on the other side.
Oh.
But technically if there's anything other than a zero, we could subtract it to this side. It would just kind of join F because F is just a constant. All of these come from one type of equation. Can you guys figure out what would be zero in order to get a line? A,
C.
oh yeah, E. I was going in order. A, B, and C would need to equal zero to be a line. Can we figure out in order to have a point, what would have to equal zero? Okay, F equals zero. Everything but F and, oh, Luke had it. Yeah, F and E, just think like a horizontal line, does that make sense? But then it would only hit the cone in one point.
Just to get an idea of what are we gonna find with this one?
All the above shapes. But it depends on what A and B and C and D and E and F are. So this is like the fully simplified one, but this probably isn't the one that you guys have seen in the sense of for lines. Haven't you guys learned y equals mx plus b? Right? For points, haven't you learned something to the effect of x and y? For intersecting lines, well, two different lines. For circles, haven't you learned x minus h squared plus y minus k squared equals r squared? How does this formula fit in that one? The bottom one is the general. The specific is what's up with the circle. How does that work? How could we make this one look like that one? Oh, you guys know? How can we make the top circle equation look like the bottom equation? Expand it? Yeah, just FOIL it all out. FOIL it all out, combine like terms. Get one side equal to 0. That's it. But, question, would you rather graph with the bottom one or would you rather graph with the top one? The top. It's all nice, the square is already completed, I see my H, I see my K as the center, my R tells me how far out I can draw a loop with, right? What are you guys doing? So question, do you think maybe there are nice, focus. Do you think maybe there are nice formulas to go along with an ellipse and a parabola and a hyperbola too, not just a circle? Yeah, we're going to study them kind of in their own sections. This section is literally just supposed to be Intro to Conics. Wait, which one? Why are we not doing lines and points and intersecting lines? Wait a minute, when did we do those? Was it 10-1 lines, but just seen in a different way? Yay! Alright, so we've already done lines, now it's time to move on to parabolas. Yay! We've done parabolas, what do we know? Come on.
Oh, it's something squared.
Something is squared, but can everything be squared?
No.
Is x squared and y squared? No, that would be a circle, or an ellipse, or a hyperbola. Parabola, only one can be squared. Only one what? What's the one we're used to? Y minus k equals a times x minus h quantity squared. That's one way of writing it, in the review way. Or we could also say y is equal to a times x minus h quantity squared plus k. Why is it called the vertex form?
Oh, because of H.
Yeah, the vertex is going to be the h and k. Algebra 1 is learning don't worry, not complete a square, that's like a whole chapter. It's coming up. But what they are learning, is there a shortcut to get h? Without things? X equals negative b all over 2a. It's one little baby piece of the quadratic formula. Why is that nice? If you really, really, really hate completing the square, P.S. you need to learn it. But besides that, for this one specific example, you can cheat just a little bit. And once you get x kiddos, how could you get y? Plug it in, plug it in. Exactly, to your original function. If it was written in the nasty, why would you be using this? Because they might give you something in this form and you're like, ew, gross, it's not what you want. Yeah, it's not standard form. Sorry, no, it's not vertex form. Let me get my plus C. There we go. It's not vertex form. Okay. Orientation and parabolas. What am I talking about? Yeah, how do they look? Question. The one that I wrote up above where I have y being to the first power and I have x's being squared, do you guys know what kinds of parabolas those are? Are those the up-down types of parabolas? Or are those the right-left types of parabolas? Yeah, up-down. Those are the basic ones that we're used to. Right? This one, just to be super basic, is going to be something of the form y equals ax squared. I'm not talking about like horizontal shifts and all this sort of this, that, and the other. What if I have y in terms of x squared? The x is being squared, not the y. What makes it concave up? What has to be true? Positive. A has to be positive greater than 0. And to be concave down like a frown, A needs to be negative. A negative person usually frowns. That's so sad. A positive person usually smiles. Okay. What's going to change to make it go right left? Because right left isn't even a function.
Log.
Oh,
Could be the absolute value of log. So
Easier
it
than
does
that, but
both
harder.
sides.
It's the inverse. The inverse says, you know what? The y gets squared instead. You switch the x and y for an inverse, right? An inverse takes a normal parabola and flips it across the y equals x line. It flips it from up down to right left. Up down, right left. Guess what's going to keep it or make it go right? A needs to be positive. Because towards the right, isn't that eating the positive numbers on the x-axis? And then it's facing the other way to the left. There we go. Does that ring some bells?
It
Which
couldn't-
one are you more used
It's
to?
gonna be log because log is only up.
Only one half of the concave, yeah. Yeah, because log will go something like this, right?
Mhm.
Okay. Shoop, shoop, shoop. Woo. Sadly, we have to get a little more technical though.
I love the sound.
Okay.
Getting some geometry in here. And you're going to solve for your very first slope of a tangent line, your very first derivative at the end of this section tomorrow. But using geometry, not using calculus. Ooh. Using geometry. Scary too. It's doing alright. I was on it a little too much yesterday. But I put some ice on it last night. I have my boot if I need to put it on.
It's still really swollen.
Not normally, but when I walk on it a lot, it starts to get kind of aggravated. Just like my ankle's not strong yet, my knee's not strong yet. Working on it.
Are you
The doctor gave me some things to try to see. She's going to see me again in like 3 weeks. So we'll see how much motion I'm able to get back just from walking on it. But I'm also like scrunching a towel and like writing the alphabet with my foot. If you have other ideas though, that'd be really cool. Just like treat your big toe as like a pointer and then like draw the alphabet because you're making your foot go through all the motions. And
Oh, that's cool.
so right now I'm just trying to build muscle mostly. Yeah, it's just like blah 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 blah.
That happened when I got my cast off. I couldn't do anything. It was just like, when I got my cast off my hand, they didn't give me any exercises
At all?
at all.
Did you like come up with one? See, mine I had to ask. She wasn't going to.
My hand was so tight, and so I just would do this every day.
Just trying to stretch it and
Yeah,
move it.
because it
And
was so, and I couldn't even like,
That's hard.
it was so tight, so I just kind of like would just do normal
Yeah.
stuff and try and do it.
It's very
And it's
hard.
fine.
that's what I was hoping like the alphabet would do. I'm like, okay, I'm gonna move it. I'm gonna...
Yeah, but it was hard because it's my left hand, so I don't use it in general.
Oh yeah. So you had to make yourself.
Yeah, so I was kind of like.
You guys got the picture?
We got the picture.
You got him? Do you guys figure out what the picture's saying?
Not exactly.
Yeah.
Not a whole lot.
This is congruent to that. This is congruent to that. That's why they're labeled with the same letters, right? And what that means is the focus and the directrix are equidistant from a particular point on the parabola. From any particular point, they're equidistant. The directrix is being a horizontal line removed in the sense that they're equidistant. That seems kind of weird, I know. However, if I showed you an example of how this works, maybe it would make it a little bit more practical. Because one way of getting a parabola is to slice a cone. Ice cream cone? However, is that the only way of getting a parabola? And the answer is no. Where's that string? True. Start studying. I would say make a study sheet that you can use for your homework along the way, right? If you use for your homework along the way, you also have it to study and or use if I say you can later. If I were to make a focus right here, what does a focus do? Think of the idea like a circle. This one would totally make a circle though, right guys?
Yeah.
Okay, so that's not good. But if you think of the focus as being not equidistant in the sense of the radius is always the same. If the radius was always the same, it would make a circle. So that's not good. So is this going to be the exact same length everywhere? No, not for a parabola. It's a similar idea, except it couldn't be the same, which is why D1, D2, D3, the distances are going to change. So a little different than a circle in that it doesn't stay the same distance the whole time. What is true to make a parabola is the distance from the focus to the point is the same to the directrix, and there's a relationship between these that we're going to see a little bit later when we talk about tangent lines at the very end of this section. So similar to a circle, and that the focus is important, but it's not the center of a circle. The distance doesn't remain the same. The distance needs to change in order for that parabola to be able to extend outwards. Now, the formulas you see below, they kind of look like the ones we just wrote. There's a square. There's a single. There's an H and a K, but what's extra? What's new? What's different? 4 and the P, right? And aren't things kind of written backwards? Yeah, things are kind of written backwards too. Let's go and check them out real fast. Things are written kind of backwards also. If you have x minus h quantity squared, this would be an up and down one, right guys? If you have an up or down parabola, depending on whether you have positive or negative in front of the x, or I should say in front of or equal to the 4p. What's different is instead of saying just a, they make the dilation using 4p instead, and here's the reason why. Do you guys see how down below there's a formula for the directrix and a formula for the directrix, whether it's oriented around a vertical axis of symmetry or whether it's oriented around a horizontal axis of symmetry? Depending on how the parabola is oriented, the directrix is going to go different ways. And so if the parabola is oriented up and down, the directrix is going to be perpendicular to the axis of symmetry. And so instead of having an x equals, what's the directrix going to have? A y equals. So the directrix is going to be a horizontal line. If it's concave up, it's going to be below. If it's concave down, it's going to be above. Sometimes understanding the graph can help you know where these are supposed to be. If it's facing right, it's going to be an x equals a vertical line on the left. If it's facing left, it's going to be an x equals line on the right. The directrix is always outside the concavity. The parabola never hits or intersects the directrix. So are there a lot of formulas? Yes. But is there a basic understanding? The answer is yes as well. Now the focus, guys, is the focus a line or a point according to our picture? Yeah, the focus is a point. Now, what's true about what's shared between the focus and the directrix? Luca, go ahead.
Real quick, now I kind of understand why the equation of the circle is x minus h squared, like in the other one, because
Yeah.
when you get them both together, they
Right.
form the circle.
Yeah. Does that make sense?
Interesting.
You guys see the axis of symmetry of this one, right? What does the focus and the directrix share if it's oriented up and down? They're both points. They share the vertical line, which means they share the, if we were to write the points, Wouldn't the vertex be 0 and a point? And wouldn't the focus be 0 and a point as well? So what do they share? The same x value. So we can use that in the sense of, okay, if we're trying to talk about the vertical axis again, so if we're trying to talk about an up-down parabola, we'll call this A, we'll call this B, then the focus for A would be the points share the x of the vertex, hence keep the h. But what do you guys think if we were dealing with a right-left one? Yeah, it wouldn't keep the x, the point would keep the y, so we would keep the k. So how are we going to get the other part of the focus? Is the focus on the parabola? Can we just plug in the x? No, it's off the parabola. How much off the parabola? Oh, I don't know. But wait a minute. In your guys' directrix formula, how far away was the directrix from the vertex? What'd you guys take away from K? P. So the distance to the directrix was P. So what do you think the distance to the focus is going to be? P as well. That is why they don't write A anymore. They write 4P to let you know that, hey, that A, if it's seen as 4 times a number, we can go ahead and use that number to help us find the focus and directrix. So for the focus, when it's vertically oriented or has a vertical axis of symmetry, the x is going to remain the same, and the y is going to look an awful lot like the directrix, but instead of k minus p, it's going to be k plus p. The focus and directrix go opposite directions, always, always. Instead of k plus p, it's going to be k minus p. And what do you guys think for the horizontal axis? Oh, I still went to the wrong notes again, I'm sorry.
H plus P.
Yep. Instead of adding to the k, we're going to be adding to the h. H plus p, going in opposite direction. P can technically be positive or negative. So if you add a positive, it's going to head to the right, or it's going to head up. If you add a negative, it's going to go the opposite direction. So P is a positive or a negative depending on the coefficient being multiplied. Now, that's a lot of technical jargon for parabolas, right? Let's do an example. And we might not be able to get too much farther for today, okay? Let's do an example. They tell us, find the standard form of the equation. Oh no, there's another standard form of a parabola. We'll just think of it. For a parabola in the conic section, we're going to use that technical formula that we just saw. Before we can attach a formula, kiddos, we have to figure out, is this an up-down one or is this a right-left one? What do you guys think if it says vertex at the origin and focus at 2, 0? What's the best way to think about this? Why don't we make a picture? Where's the origin? Psh, easy cheesy. Where's the focus? Guys, do you notice how the parabola, look at your pictures above, doesn't the parabola eat the focus? The parabola focuses on the focus, it eats it. So if it's eating it, which orientation does this parabola have to have? Yeah, it has to eat it, see? Well, if it's going that direction, aren't I going to have one of the ones where I have, let's see, isn't it y minus k squared equals 4p x minus h squared? Isn't that the formula I'm going to plug into? No. Only one guy gets squared. The y needs to be squared. It's a right-left one. It has a horizontal axis. But what are some things I can label to help me plug into stuff? Well, I have 0, 0. And what's my distance for p? Why is it positive 2? Because I'm going to the right, or to the positive way 2. So p is a positive 2. So all I have to do is say, oh, sweet. Hey, isn't hk my center? So I can plug in 0, 0 as my center. And then what did I just say, or what did we just figure out, is p, the distance of 2. Oh, well, that's cool. Now, do we leave it like that? No. We should make it a little bit prettier. We could say y squared is equal to 8 times x. If you want to, another way of writing it is to get x by itself, since it's like an inversey one. You could say 1/8 y squared. Either one is proper. Either one is okay. Does that make sense? What if they tell me a different clue and say, sweet, still use the origin idea, but now the directrix is at y equals 1. Where's the directrix? Top, bottom, right, left? Good. Y-axis. Make a little ch-ch-ch-ch-ch. If my parabola cannot intersect the directrix, it goes to the right. Nope. It goes to the left. Nope. It goes up. Nope, nope. Must go. The directrix cannot hit my parabola. Question. Do I still know 0, 0? Pause. Do I still know 0, 0?
Yes.
What's my P?
It's got the one.
Struggle. Why is it a -1? Because my poor little parabola is going down. Bye guys, I'll see you later. The ones you took 2 days ago?